is we looked at the main ingredients of bath bombs. We looked at Epsom salts, citric acid, baking soda, lemonade, um, olive oil, and coconut oil. And we looked at how they interacted with one another. We used water, which Lillian, are you here, Lillian? I thought I saw you. Yes, you are. There you are. Miss Beckwith, I guess I should say that. I have two Lillians here. Uh, what is another name for water? What else do we call water?
A universal solvent.
Or universal solvent. Very good. Um, so we didn't look at adding water because I mean water was on all of them. We put water in everything, and that is what we're using to dissolve parts of the bath bomb into solutions. And Manvitha, what when we put a powder into the universal solvent, what is that powder known as?
Can you repeat that?
Okay, so we put a powder into water. Water is a universal solvent, and we're trying to make a solution. What do we call that powder? What is the powder? What are we dissolving?
The solid, isn't it?
Oh, say that again.
Solute.
A solute, yes. Thought you said solid for a second. So a solvent and a solute make a solution. And we're making solutions. And our purpose was trying to see what react, and that's fine. You have nothing to be sorry about. I mispronounce words all the time, so yeah, you don't worry about anything like that. A solute and a solvent mixed together, they make a solution. Now, I am not sure if I covered this with this class or not, but Miss Markham, are you with us?
Yeah.
Okay. If a solute dissolves in a solid, what do we call that? What is the ability of the solvent to dissolve in, or a solute to dissolve in a solid? Did I cover those with this class?
Oh, yes. Yeah.
So what is the name of that? What do we call it? Is it if it is able to dissolve?
I don't know.
All right. Rashish. Do you remember, sir? All right. Does anybody remember? Merrick.
Soluble.
It is soluble. Very good. So if something is able to dissolve, we call that soluble. Sanish. Oh, all right, Sanish, you're jumping ahead. You're posting all kinds of answers as I'm trying to question people. But Sanish, what do we call it if it is unable to dissolve?
Insoluble.
Insoluble. Okay. So what I'm going to do is I am going to try something new here. I'm going to try a split screen. I have not used this yet. Let's see. Actually, I think I need to do it this way. I think I need to first.
Mr. Schillinger,
Yes, ma'am.
if you need it, I'm pretty sure the shortcut for putting your screen is Control Shift Bracket or something.
Okay. Well, that should be fine, but what I'm wanting to do, I mean, I have a link right on my top of my Chromebook for it. All right, so I'm assuming in just a second, you are all able to see, maybe. Come on, I just told you to start presenting. There we go. A little slow. Am I presenting to you guys? It says I am presenting. All right. Really, don't tell me I closed my slides. All right, bear with me for a second. I am probably one of the most disorganized teachers you're ever going to see. All right. Hopefully that's not 100% true. But let me go ahead and open this tab back up. Go to my Google Drive. Recent. As we all fall asleep waiting for my computer to work. All right, there we go. Well, maybe. Okay, so we're not going to follow these slides verbatim, word for word. Like we're not going to do a turn and talk because it's kind of hard to turn and talk when we are on the computer. Come on. All right. So can you all see my presentation? Are you all still with me?
I can't see your presentation. It's just all black, and then
I can't see it either.
I can see you, but not your presentation.
It just says loading for me.
Okay.
I see your screen, so.
All right. Forget this.
I just see, and then underneath that, there's a little bar that says slide 1, and I can't read what the rest of it says.
Okay. That's fine. All right. So we're just going to go ahead and do it this way. We're just going to do it old-fashioned.
Oh, good enough.
It's working now?
Okay, it was working before, but now it's just loading again.
Well, okay. Something popped on my screen, but not what I wanted. Okay. Do you guys see that?
It works. Yeah, I see how it works.
Okay, great. So we have looked at a few different things, and it says right here in turn and talk, and I'm just going to call on a couple of you. Just because I close the split screen because I think it's too much for my computer to handle right now. I'm not looking at the chat log, so I'm going to ask you to please come on as I call your name and give me a verbal answer to what I'm asking you. So, Alexa, are you with us?
She's not here.
She is not here. Wonderful. Okay. Rochelle, are you here? Okay. Shrog, are you here?
Mr. Schillinger, I can't hear you.
You can't hear me now.
Yeah, I can't hear you either.
Not again. Maybe you should go to the technological help people at Fulbright. Staff have been assigned to the embarrassing moments spread, but for virtual students, it's so easy to do. Just literally all you have to do is list one time that like somebody was unmuted when they were talking or something. I don't know.
Okay, I'm back. So for whoever, as I was leaving, somebody said I should go to the tech department. Can you hear me now? Yes, no, maybe so.
Yeah, I can hear you.
Okay.
I can hear you.
I have gone to the tech department. They are trying to get me a new computer. So my computer is just in need of replacement. So what I'm doing right now is I am uploading a Google slide to you. We're just going to go ahead and do it this way, which, you know, it's what it is. Today is WD Doma slides. All right, if you go, okay, now this just running pathetically slow. All right, so I am posting the slideshow. Go ahead and go to Google Classroom. It is called W11W Slides. Go ahead and open those slides up. Does everybody see the slideshow?
Not yet, sir. I have it up.
Okay. So not exactly the way I wanted to do this, but this will go ahead and work for us. So, Shrey, how are you doing today, sir?
I'm doing good.
All right. So, Shrey, in slide A, on the first slide, it said, what evidence did we use to conclude that the gas in the bubbles was not one of the three substances we started with, baking soda, citric acid, or water? So how do we know that the bubbles were not contained in one of these basic ingredients? And let's even expand that to the lemonade and olive oil and coconut oil. How do we know that the bubbles weren't contained in any one particular item?
Because in most of them there wasn't there was like no reaction with
Yeah, I mean, that was it exactly. I mean, we went through this list of materials, and none of them gave us a gas production. You know, we had, they dissolved. Lemonade made the water cloudy, but we didn't see any kind of reaction in any of the substances when we tried them just with water. Correct? I mean, does everybody agree with that? All right. So if we, you look at slide number 2, it says scientists can identify different substances based on their properties. If we want to figure out what the gas in those bubbles was, we could also try to identify the gas based on their properties. So what are some different properties of substances that are gas at room temperature? Does anybody know? Raise your hand or drop a comment into the chat box. What kind of substances, what gases do you know are in gas form right now?
Like, what do you mean by that question? Like, that got caused by the chemical reaction, or just like?
Well, no, just gases that you know in general.
Carbon dioxide.
Okay, carbon dioxide. Manvitha?
Oxygen.
Okay. Well, you weren't Manvitha, Merrick, but you know, oxygen. Lily says oxygen. Vedant, the problem with air is, while it is a gas, it is a lot of different things. Okay. Air is probably 30 or 40 different gases combined. Okay, methane, Sanish, helium, Trey, nitrogen, Merrick, steam, Lily, which is water in vapor form. What about, let's see, Merrick said nitrogen, carbon dioxide gas. So I mean, we have a lot of things that are gas at room temperature. We know these. You even go to your stove. You have, depending on where you live, you might have propane. I live out in the country, so I don't have city gas. So, we fill up big tanks of propane. Or if you have a barbecue. Manvitha, move, Manvitha. I think Manvitha's frozen on us.
Wait, what?
Oh, there you go. You jumped all of a sudden. You looked very frozen there for a second.
Yeah. I think I may just turn off the background effects. They're slowing my computer down.
Yeah. All right. So we have a lot of different gases. Now, one of the properties of these gases, all right, I noticed that somebody here said, okay, Rashish said it, and so did some other people, but I see he was the last one that said it. Merrick, Shrey, helium. What is a property of helium that you know that it does?
It's lighter than air.
It's lighter than air.
And it wants to float up into the sky. That's why a lot of people use helium.
So it's lighter than air. Okay. This is an interesting concept, which a lot of you may already know. But so lighter than air.
Mr. Younger, I can't see like your whiteboard because you're really blurred.
I know. I'm going to turn on my light. I'm going to go walk around my classroom. Okay, so lighter than air. Helium, is that better?
I mean, I can see it now, yeah.
Okay. Isn't helium in those balloons that go into the sky if you don't hold them? Yes, it is, Vedant. So we fill up balloons full of helium. So do you remember when we put the oil in the water? What happens to the oil?
It floats.
It floats. Okay, kind of Booby, okay, I just went back to see what you wrote here. Different gases have different densities. For example, helium has the ability to float because it is lighter than air, oxygen and carbon dioxide. So that's actually where we're going, Booby. Sorry, and I didn't see you actually say that a few seconds ago. But so water floats on top, or excuse me, oil floats on top of water. Helium rises above normal oxygen, things like this. If I put a piece of wood in water, does wood float?
No.
Really?
Yes. Yeah, most pieces of wood float.
Wood floats
most of the
at
time
first. Now, Lexi, I
I
think
think it would depend on
you think it would what?
the weight because you could put like a wood log in the water and it would probably it'd sink down.
Not at
It
first.
kind of depends.
If you look at, like if you were to Google logs on a river, what they do in logging areas that have big rivers is they will cut down a whole tree and they will drop it in the river and they will float that log down to mills. I mean, we're talking 40-foot long, trees that are like this big around, and they'll float them down the river. Have you ever seen somebody on a log running on the water and the log is just spinning? Wood floats, but I think what you're thinking of, Lexi, and a lot of us think wood will absorb water. When the wood absorbs all the water and sits in a lake or a river for so long, then it sinks. But at first, wood floats. And the reason is what Bouvier said is it is less dense than the water. Helium is less dense than oxygen, so it rises. Wood is what converts oxygen to carbon dioxide. No, wood is not what converts oxygen into carbon dioxide. That is a chemical reaction. You can't convert oxygen into chemical carbon dioxide. You can add carbon to oxygen to make carbon dioxide. That's okay, Manvitha. We'll come back and talk to that. So what is, and let's stop putting the answers on the board for a second. I want to get somebody I haven't talked to yet. Avinash. Are you there, Avinash? Okay, no response from Avinash. Jay, are you there?
Yes.
All right, so Jay, what is density?
It's like kind of like weight, but not really weight. So like the more dense, the more it will go down and like sink. If say it's water, the more dense it'll sink, the less dense it'll float.
Uh-oh. Hold on a second. I'm having the inability to spell. Hold on. D-E-N. Oh, that's right. Okay, I spelled it right. Lexi.
Density is like how compacted something is.
Okay, hey, hold on one second. So it's how compacted something is. That's one way to say it. If I actually look at the formula for density, it is mass over volume. So it's how much mass, how much stuff is in a given amount of space. How much matter is in a given amount of space. Okay? Water, for every 1 milliliter of water, it has the mass of 1 gram. Density is mass divided by volume. Okay. Avinash, let's see. Can you hear me, Avinash? If you can't see anything, you might want to leave and come back. That might solve that problem. Okay, so certain gases rise. This is a property of gas, their density. This is a chemical property. And the thing is, at a given temperature, density does not change. It's always the same. Now, I can change the temperature and I will change the density. Because remember, what happens when molecules get heat? Samuel? If I were to add thermal energy to a molecule, what happens to it?
It goes faster.
It goes faster, so it starts to move away, right? So if I heat something up, am I making it less dense or more dense?
Less dense.
Less dense. So that's why I can take a hot air balloon, these big balloons that people float around in, and I can just heat the air. I just put a burner under it. And I just start making that air warmer and warmer and warmer. And all of a sudden, my balloon flies away. It's just because I've heated the air. I've heated all those different gases that are inside that air. I've heated them up so they're moving away faster. So therefore, my density changes and it starts to float. Does that make sense? Sanish, heat does not rise. Heat is energy. Hot air rises. Why, Angelina?
Hot air rises because it is the particles move faster than cold air.
Right, so we've just made hot air less dense than cold air, right? So therefore, it rises. Sanish, we are used to saying heat rises. But what it is, it's whatever we're heating up that's rising because we've changed the density. Ms. Markham, does that kind of make sense? Ms. Markham?
Yeah, it makes sense.
Okay. Heated toasters rise. I don't know exactly what you mean by that. Yes, technically we can say air rises if it's heated. Hot air rises. Okay. I want you all to look at slide C, which is the third slide down here. And these are the most common gases that are in our atmosphere and even around us. We have nitrogen. 78% of our atmosphere is nitrogen. It has a boiling point, or it turns into gas, at minus 196 degrees Celsius. Its density is greater than oxygen. It's 1.2. Excuse me, it's less dense than oxygen, 1.2. And it will extinguish a fire. It will cause a fire to go out. Oxygen, 21% in our atmosphere, minus 183. It will cause a flame to increase, cause glowing embers to burst into flame. Argon will extinguish a flame. Again, its boiling point, minus 186 degrees. Carbon dioxide is approximately negative 0.04% of gas in the outside air. Now, why does that say negative? This changes straight from a solid to a gas. Oh, it's actually not negative. That is actually a less than. So it's less than 0.04% of our atmosphere is carbon dioxide. It's heavier than oxygen. It will extinguish flames. And if we look at most of these gases, I'm not going to read each one of them. Half of them will extinguish a flame. Half of them will cause a flame to ignite. Okay. Can we see that? Do we all kind of agree with that? Sort of. Okay. So what we want to do, if we go down to the next one, it asks you, what will happen if I take a match and I put it in a jar with room temperature, or excuse me, with air from the room in it? Now, unfortunately, I don't have helium, because slide D says, how about if I place the match in a bottle filled with helium? We are unable to get any helium right now.
Mr. Schillinger,
Yes.
will the bottle / jar be sealed hypothetically?
Will it be sealed?
Mm-hmm.
I can put a cap on it. Actually, I need to go get a cap. Hold on a second.
How would you even keep the helium in the bottle?
Well, if I had helium, is helium heavier or lighter than air?
Lighter. Well, you could turn the bottle upside down.
Exactly. That's all I'd have to do is just turn the bottle like this, and the helium would stay inside the bottle. All right.
Just buy a balloon, then you'll get plenty of helium.
So you guys see my match? I put it inside and I cap it. It burns for a second, then goes out. Let me try that again here.
Yeah, because fire needs H2O. Or no, H2O and oxygen.
Fire needs air, but when it consumes the air, it burns the air away. So when you put it inside a sealed space, then after it burns all of the air out, it burns itself up.
Oh, very good. So basically then, I can do this and leave my match burning, correct? For a few seconds. I'm just really hoping I don't set off the fire alarm in here. It keeps going right out on me. I think I don't have any more fresh oxygen in my bottle. All right. So it burns for a few seconds and goes out, correct? And technically, it should keep burning on me. There we go. If I do it this way, it keeps burning.
Are you afraid of it melting the plastic?
Well, what plastic?
I'm pretty sure that's made of glass, isn't it?
Yeah, this is a glass beaker, a glass flask.
A ruined glass beaker now. Well, is it? I mean, we can all see the black marks on it, but
Yeah, and the thing is,
is it really ruined?
You can just wash it once it's cooled down, and then it's normal again.
yeah. And let's see here. Wash, wash, wash. So I've cleaned my flask. Kind of, little soot still in there. I've put some water in it. So, let's see here. Let me see who I want to talk to.
Mr. Schuster,
Yes, sir.
will coconut oil catch fire?
No, no.
Never mind then.
Now, actually,
I was thinking, if we put one of the cooking oils on top of the water and then set it on fire, technically it would burn on top of the fire would burn on top of the water, right?
well, do you know that oil does not necessarily burn right off? You have to heat it up. Oil does not burn. Gasoline does not burn. The vapors burn. Did you know
I
that?
have a prediction for the helium.
What is your prediction for the helium?
I think the flame is gonna burn out because in the last slide it said that helium will extinguish a flame. So if you put a flame by itself into a bottle full of helium, I predict that it'll burn itself out.
And it would. Unfortunately, like I said, though, I don't have helium. But what we are going to do real quick, I wish I did have helium. I actually have to talk about this with my other teachers and see if we can acquire some helium. Avinash, thank you. What if you can't create or destroy matter, then how was the universe created? Well, Avinash, that gets into a very philosophical question, which basically, if you believe in astrophysics and what they say is before the universe was created, all matter was contained in something about the size of a period in a book. And dark matter and dark energy actually, created the phenomenon that released all that matter to create everything we have today, aka the Big Bang. All right. What I want you to predict, and I'm going to have, let's see, Lauren. How are you doing today, Lauren?
Good.
Good. So, Lauren, what do you think? Now, I mean, there's a bunch of different kind of gases that could possibly be produced when I drop one of our bath bombs into this water. What do you think is going to happen when I put the bath bomb into the liquid and I strike a match and see if it burns. Now, I want to show you right now, just to make sure we understand. When I take my match, I have the flask full of water, and I put it in here, the flame does not go out. You see that, right? Woo! Ow. So what's going to happen when I do that as the bath bomb is reacting? What is your prediction?
I think all the little powder bits of the bath bomb would catch on fire, and then I think it would slowly burn itself out.
Okay, so you think it's going to help the fire?
Because it has all of those substances in it, and bath bombs tend to be quite dry, and dry things are a good kindling for fire.
Okay. This sounds like a pretty good test then. How many people, just give me a thumbs up or a thumbs down for those of you that are on your camera, think she is correct? Okay. Merrick, you have a question?
So if we believe that the matter can be created or destroyed, and the thing goes up and it creates a gas, which we said was true, like it creates a gas, then wouldn't depending on the type of gas, the gas could either extinguish or keep the fire going.
Right. And Lauren and probably about 5 or 6 other people believe that it's going to help keep the fire going. Now, we're not there yet, but we're going to try to determine what the gas is. That's where we're going with all this. Okay, so I'm going to have to do this relatively quick. You guys can see my my bottle. I'm going to drop the bath bombs in. They are fizzing. My match went out almost instantly. It's still fizzing. Oops. It went out before I even got to the jar. Went out before I even put it in the jar. Whoa. Look at this. Starts to go out before it's even in there.
Light dimmer.
Lexi.
So I think the bath bomb's causing like carbon dioxide, which is going up.
So you think it's carbon dioxide?
Yeah.
Well, if we look at our chart, what does carbon dioxide do to a flame?
It kills it. I mean, extinguishes it.
Okay. But it could be argon. It could be nitrogen it's making.
Well, I mean, it could, but we like discover it was the bath bomb was making like I don't think the bath bomb could have made argon or methane. Yeah, against the school safety measures, and carbon dioxide is much more common, and I think it's carbon dioxide.
Okay. Well, now one thing, Lexi, question or statement?
I know whenever I was doing my like statement thing for like what do you think's causing the bath bomb reaction? I know like citric acid and baking soda, I think was it,
Right.
come together and that causes the chemical reaction. And that chemical reaction can only be caused if there's carbon dioxide from the chemical.
Interesting. Very, very interesting. We're going to have to expand into this a bit, I think. All right. So here's what I want you to do is go to slide go to slide number 9. or I, and there is a prediction statement. And what I'd like you to do is I want you to submit your statement into a Google Classroom. There's going to be a doc there. I'm making it right now. Let's see here. I'm going to try to make it so you don't. Oh, come on.